Hello and welcome back to this Fundamentals of Machine Learning tutorial. In this video, we'll have the K-means clustering lab. This tutorial includes generating synthetic data, visualizing it, and applying K-means clustering to identify patterns. Synthetic data is artificially generated data that mimics real-world data. So, to start with, let's set up our environment. So open Google Colab, click on New, click on File and New Notebook. Then the next thing, after clicking on File and New Notebook, next thing we'll do is import the necessary libraries. Import Python libraries for data manipulation, clustering, and visualization. So we have used the first three. We've used NumPy, Pandas, and Matplotlib. We'll then move on to make blobs, which is what we'll use to generate our synthetic data, and K-means, which is the data for which is our clustering algorithm. So from sklearn.dataset, import make blobs. From sklearn.cluster, import K-means. So let's import all of this. So click on code for a new code block. There. So now let's generate the synthetic data. So we can create synthetic data using MakeBlobs. MakeBlobs is a tool from scikit-learn used to generate sample data that is perfect for clustering experiments. The MakeBlobs function generates blobs of points centered around a specified number of centers. Here, 300 samples are generated and grouped around 3 centers. So the simple n samples equals 300, centers equals 3, and random states, that's the seed for splitting reproducible data. So data frame creation, the generated data X is then organized into a data frame for easier manipulation and visualization. The columns are named feature 1 and feature 2 for simplicity. So the same way you have created the data frame in the previous videos. So here we have X, data equals to X, and we're storing that in synthetic underscore df. So let's see this. There. So now let's visualize our data. So you already know about the scatter plots. So that's plot. Remember, we saved matplotlib as plot as the alias for it. So we visualize the data to understand its initial distribution before clustering. So because our column names are feature space 1 and feature space 2, that has to be this column names as well. So plot the scatter, we want the first feature, comma the second feature. So this is it here. So we have 300 points in 3 centers as we stated in our make blobs. So now let's try to use K-means clustering on this. So apply K-means clustering to group the data into clusters based on their features. So remember how you had logistic regression and you stored it in a variable model. Here we have K-means and we're storing it in a variable K-means underscore synthetic. K-means can have 2 parameters like n underscore clusters, the number of clusters you want, that's the number of groups you want, and random states. So let's put this. So then the next thing, after you store your K-means and K-means synthetic, you want to use this K-means or synthetic to fit predict your synthetic underscore df, which is this here, your data frame. So and then you're going to store it in like a new column cluster, the same knowledge from the data frames session. So now let's try to visualize the clusters. So plot the clusters and centroids. So visualize the cluster data along with the centroids to observe how k-means has grouped the data. So let's do that. So here we have two plots that scatter. So the first one, we're scattering the synthetic df_df feature 1 and feature 2, C equals synthetic df cluster, CMAP, Viridis, and alpha 0.5. So alpha is more about the transparency, how transparent or opaque you want it to be. We also have CMAP, which is short for color map in plotting libraries like Matplotlib. So it's used to specify the color scheme used for plotting. So a color maps data values to colors. So in a scatter plot like this, CMAP equals Viridis would use the Viridis color map to color the points based on their values. That's what we have. And so C is just a parameter used to specify the color of markers in plots. So here we have C equals to red, so that's going to be the color. So we're scattering the centroids of colon 1. So remember, the centroid is just the cluster center from our k-means synthetic here, and we'll fit that. So the cluster centers for it will be stored in centroid. So we have the centroids, scatter the centroid, this one, and we have C equals to red. That's going to be the color of the marker. S equals to 50. So S is just a parameter used to control the size of the markers in the plots, and the marker will be X here. And then title, what we've covered before already, we have the title and so on. Oh, sorry, hasn't been run yet. So then we run this. So here. So if you want to increase this, you need to increase S. You can change C equals to red, change the color, and so on. So now let's see the summary of what we've done. So we use k-means to organize the synthetic data into 3 groups. The fit_predict method not only fits the k-means model to the data, but also returns each point cluster label. And visualization. By plotting the data points colored by their cluster labels and marking the cluster centers, you can visually access how effectively k-means has performed the clustering. So now let's try using a real data set. So the iris dataset. So this is a dataset of iris flowers. So first, import all necessary libraries for handling data and performing clustering. So we have imported 4 of this already. We haven't imported standard scalar, and we also need to import the iris dataset. So from sklearn.dataset. So this here has a lot of datasets. You can search various datasets you need. And also from sklearn.preprocessing, we're importing standard scalar. So you can visit the preprocessing video to remember why we may need to scale. So next we need to load the iris dataset, and here it is being stored in the variable iris, and we can then create a data frame from that iris dataset. Remember, using pandas.dataframe. The columns will be the feature names that comes with it, and we can also see the first 5 columns with data frame, the name of the data frame .head. So put load iris in the variable iris. Then we have this data frame here. So the iris.data. So if you check the documentation of the load iris, you'll see that the data is stored in .data. And we can print the first 5 rows and along with their columns. So this has 4 different features. You have sepal length, sepal width, petal length, and petal width. So they're flowers. So so that's why they have these features. So now let's visualize the sepal features. So visualize the data to understand the distribution of sepal length and sepal width. So just 2 features for now. So if we want just 2 features, remember we'll pass in just the 2 features we want in plot.scatter. So here, plot the sepal length cm and sepal width cm. And here it is. So these are the points. So for one of the flowers, when the sepal length of that is 4.5 and the sepal width is around 2.3. So now let's pre-process the data. So you can scale the features to normalize the data dimensions for better clustering results. So we can use standard scaler. So now let's apply k-means clustering. So remember, the same way you have you just call other algorithms when you want to, you call an algorithm when you want to use it, is the same way here. So we called k-means here, and we pass the number of clusters we want. So if we want 3 clusters, you put 3 here. And you can store it in a variable k-means. And remember that fit underscore predict. So you know how you have, so this fit predict is basically like training it and predicting. So the same way you had the fit and predict for the other algorithms. So you want to k-means a fit predict df underscore scaled. So the scaled value we have. Remember, we stored the scalar.fit transform in df underscore scaled. So now we also want to put the clusters in our data frame df cluster. Okay. So now let's visualize the clusters. So the same way the plot for the synthetic data is the same way for this one as well. So here our marker is bigger because s is equal to 200. Previously s was equals to 50. So if you want a bigger marker, simply just increase s. So here we've been able to use k-means to group this into 3 different clusters. So this is how it looked before, and now after scaling and clustering, this is how it looks. So it's able to put this into 3 different groups. So now let's try to predict on new data and visualize. So the trained model can be used to predict a cluster of new samples. So let's do this. Okay, so we have like this pd.data frame, we have 5.0, 3.5, 6.0, 3.0, 7.0, 3.2. So here we only have 2 features, even though the data frame had 4 features. Remember, we are only using sepal length and sepal width for now. So using this column, so new data pd.data frame and new data scale it again, new data cluster. Remember, creating a column cluster for that, and we want to put what we predicted using that k-means on this new data. So let's run this. So here, so it's saying the first one will go in the first cluster, the next one this cluster, and the one that's 7.0 and 3.2 this cluster. So when it was 5.0 and 3.5, 5.0 and then on this axis here, and 3.5 on this axis, so that point is around here, and you know that points around here will be joined to this cluster. Based on our visualization, we can see that is the cluster it will go to. If we have 6 and 3, it will go to the one with the green cluster because this is closest to that one, and if we have 7 and 3.2, it will go to the one with this cluster. So that is all for clustering, but if you have any questions, feel free to leave it in the comments below. And thank you very much for watching. See you in another video.